This will be my first test of trying to actually melt a ferrous material. I've melted a bunch of copper before, but never iron-bearing materials. So the idea here will be to melt, I don't know, close to 300 grams of cast iron and be able to pour it into this graphite crucible that I've made. This cast iron is just pieces that I got at a local online auction. I don't even remember what they were now, but they were just something that from the past that I figured I could break up and use. I have this pan here of dry sand, and the reason that I have this here is that in case I get a lot of sparking, or if I screw up when I'm pouring, that I won't have molten cast iron running around on the floor or getting to me personally. So it's a safety precaution, which I may or may not need. This is beach sand that I picked up on our own little beach at our pond up in the woods, and sifted and dried and tried to get rid of all the organic material that I could, and even did a little testing of it with a propane torch to make sure there wasn't a lot of stuff that could remain flammable in there to create a problem or cause steam from being damp when I actually do the pouring. This is a setup to make a small graphite mold for my attempt at melting and pouring a little bit of cast iron. Right here is a block of graphite that a guy gave me years and years ago. It's roughly 4 inches wide and 1.5 inches deep and a couple of feet long. And so right now I have a cardboard dust protector around the area that I'm going to machine, and I don't know if this is going to focus well or not, but I've got a 2-inch by 4-inch area laid out, and I'm using a 1/2-inch end mill, and I've got it set in 1/4 inch from each corner. I've pre-drilled a hole 1 inch deep because this isn't a center cutting end mill, and so I'm going to plunge down there and I'm going to attempt to just mill out that cavity so it'll be 2 by 4 inches by 1 inch deep, which will hold the amount of molten cast iron, if I get that far, that I hope to produce in my 2500 watt induction heater. And here I've got my X and Y DRO set to roughly zeros, and so I'll be going inside a 2 by 4 cavity, a 1/2 inch less than 4 inches long and a 1/2 inch less than 2 inches wide. So, and backing up to be right over my hole, and I'm going to crank in 100 thousandths of depth. See what happens. I'm going to go to 3.5 inches. Lock that axis. Like that. To zero. Now I'm going to shut the thing off and suck up all the graphite dust. So I lost track of where I was, so I want to see how far I went here. And I went 300. Okay, so that's it. I don't think you need to see me go the rest of the way down and clear out the center. So anyway, that's the plan for making a 2" by 4" by 1" deep graphite mold, and I'll saw that off in a bandsaw after I'm all done. For this cast iron melting video, I'll be using my 2500 watt induction heater setup. And to make this go as smoothly as possible, I've made several small changes to the heater setup, specifically for this cast iron melting attempt. The first thing, which is really simple, that I've done is to add this shield here between the work coil and the circuit board and stuff, so that in case there's a lot of sparking that happens as I remove the molten iron, or whether it starts sparking as it approaches melting, there'll be less of a chance for the sparks to be able to get over onto the electronics and hurt something else. The next big change that I've made is due to the fact that when I fill a graphite crucible like this with cast iron, I am chunks of cast iron, which I'll be using for the test. I'm expecting that I will easily go over current, and I can probably go with the 2500 watt unit up to about 50 amps, okay, but I can't go to 60 or 70. So normally what I've been doing when I'm melting copper is I drop the crucible all the way into the work coil, and maybe I'll get currents close to 45-50 amps with a fresh thick-walled crucible when I'm melting copper. And that current actually goes down some just as the copper melts. Then if I'm using a crucible which is worn, it becomes thinner and thinner every time you use it, then that current will drop off another 6 or 8 amps. However, I suspect that if I have iron bearing material in this graphite crucible and I try to drop it all the way into the work coil, I will clearly be exceeding the current capabilities of the system. So of course I don't want to do that. So what I need is a way to incrementally drop the crucible down into the work coil. So my thinking is that a plain graphite crucible without anything in it and fresh may suck up about 35, 40, maybe even 45 amps even without any metal in it at all. On the other hand, if you've seen my other videos, if I put this steel piece of tubing in there, I can't stick it down there very far at all without it exceeding 50 amps on its own. So what's going to happen when I have this thing full of cold or below Curie point iron when I stick it in here? I suspect, and we will get to see, you and I for the first time, what happens as I try to stick this combination of crucible, which is capable of 30-40 amps all by itself, and iron, which is capable of 30, 40, 50, 60 amps all by itself down in the crucible. So since I don't want to blow up my setup, but I do want to actually try to melt some cast iron, I created a little jack down in here. I know it's really simple, but all it really consists of is a little cylinder of wood with a bunch of holes in it and a dowel which can poke through any one of the holes, thereby raising my dowel, my jack. By raising, it can raise the jack up into the work coil. The dowel that you see right here just keeps the jack from falling out the bottom if I screw up. So the jack, of course, is made of wood. It's just a piece of dowel. So to keep the dowel from just burning up, I've got a couple of sort of round flat pieces of fire brick. Here's one that's about 3/8, 7/16 of an inch thick. And here's a piece that's about an inch thick that I've used for other experiments. And so I will drop this down inside on top of my on top of my jack and then set the crucible in on top of that. And then by raising and lowering the jack and picking a different dowel position down below, I can set the height of the crucible wherever I need it to get the current as high as I can afford without going over current. And then, in the case of ferrous materials, as we know, once the ferrous material reaches the Curie point, the current drops significantly by maybe as much as half or so. And of course we don't want that because we really want to melt this cast iron. So the idea here is that I will make an experiment, which you will see, and we will see how far I can stick the filled crucible that you saw at the early part of this video when I was showing the mold in the sand, how far down we can place it safely, and then as we reach the Curie point, we'll be able to lower and lower and lower the jack at watching the current all the time so we don't exceed maximum safe current. And then hopefully at some point we'll be able to melt this cast iron and maybe even get it a couple of hundred degrees past melting so that we've got time to pour it into the mold. So you and I are going to see if this works or not at the same time. This is going to be a short test preceding melting some cast iron or attempting to, just to see roughly how far down I can insert crucibles with and without ferrous material, in this case cast iron, so that I can get an idea of where to set my little jack that's under here. First crucible I'm going to test is a new one, has a pretty thick wall. They wear out as they go. So I'm going to see how far I can stick this down before I peg the meter at 50 amps. And I think we'll be okay with this one. Okay, so here we are, just touching the top at 2 amps, 10, 20 amps, about halfway in, 30 amps, 3/4 of the way in, and 38 amps all the way in. That's a new crucible. Now, here is a worn crucible. I don't know if you can see it or not, but the wall is a lot thicker, and it also doesn't have a rim around it, and it's full to the brim with cast iron, which I will weigh. I don't know, it's probably around 300 grams or so. So here we are, 6 amps, just touching the top of the work coil, 12 amps, 20 amps, I got about ½ inch in, maybe 3/4. 30 amps, I got about half in, a little more than half. 38 amps, 40 amps is about a 3/8 of an inch sticking out yet. And there we are, hey, that's going to work. 42 amps all the way in. That's great, I think. Okay. Now, I'm going to dump out the cast iron and test this one again to see how much current it draws. Hang on while I go get a piece of metal to pour this onto. Well, I guess I'll try pouring it into the little mold that I made that I'll hopefully be pouring molten cast iron into shortly. So here now, this is the thin-walled, worn-out crucible without a lip on the top. And for comparison, here's what I mean by a lip on the top. Okay, crucible just touching the top of the work coil, 8 amps, in maybe ½ an inch, 16 amps, in halfway, 30 amps, in all the way, 40 amps. Okay, that's really the test for the moment. If you previously saw my little video about the jack, which is not the focus of this video, this is it, and it just fits in a hole here. There's a bunch of holes here, and with this dowel I'll be able to pick the height that I want for the jack, and that's why I'm making this little video, is to just get an idea if the jack was going to work, and it is. I've already checked it out, and I've got plenty of positions to do what I need to do. And besides, as a matter of fact, we didn't go over current at any point, which kind of surprised me. We'll see what happens later on. I did have a plain flat piece of insulating material under here, but when I built the jack, I had to have a hole in the material. So I took the time to make another piece that just fits in there, and actually cut this hole with a 1.5-inch hole saw. I don't know if I destroyed the hole saw or not, but anyway, now I have additional insulation between my plywood base and the work as I heat it up. And of course, on top of the jack, as I mentioned earlier, is going to sit either 1 or 2 pieces of ceramic material to further insulate the wooden jack. Okay, back to just about 6 amps idle current. I don't know if I'm going to keep this whole video or not, but earlier I turned the system on, and I had gotten a 2500 watt unit, my own, back from some guys who borrowed it for a few weeks, and they sent it back to me and were very nice about it and all that. I connected it back up, turned it on, and it worked. But today when I turned it on, it was dead short. It wasn't oscillating at all. By the way, the open circuit current, or the no work in the coil current, is again just about 6 amps, and the frequency is 38.3 kilohertz. Just for the heck of it, I put the iron back in, and of course some sticking out the top because I didn't shake it down well. Again, 38.3 kilohertz, and as I put this in, I go up to 41, 41.8, 43.1, all the way down, again 42 amps and 43.9 kilohertz, in case you're interested. But you can see with the ferrous material, the frequency actually went up. Okay, that's the end of today's test. I now know that actually, after going to all the trouble of making the jack, I don't need it at all.